And I've got the microphone open so people can ask questions, Sean, and we should be good to go. So take it away, Sean Feldman.
Thank you, Ari. Hi, folks. I cannot see you, but I imagine you're a nice audience. I'm Sean Feldman from Calgary, Canada, province of Alberta, if you're familiar with geography of Canada. This talk is an interesting one because I was contemplating whether to go with just a frontal presentation or to make it a little bit more conversational. And I decided to make it somewhere in between. So while I'll have a few slides, I'm not going to do live coding because it's just a waste of everyone's time, to be honest, especially if you run into issues. But I do want to engage questions and conversations, not at the end of the session, but throughout the session. So don't feel like you're interrupting anything. If you have a good question, please raise it.
There we go. And now you can see everyone.
Awesome. Now it's almost like in-person presentation.
Totally the same.
Yeah. One thing, I won't be able to monitor both screens. So if you have a question, just ask those or indicate to Ori somehow. Because if you're an extremely polite person and raise your hand or you're a Canadian, I won't be able to notice. So that's the only ask. All right. So it's kind of double-edged sword, this presentation. Azure Functions making sense of it and also moving from one SDK to another, or goodbye in-process, hello, Isolated Worker SDK. It all will make sense. And if you're not familiar with Azure Functions, that's fine because I have a little bit of introduction. It's going to be from 0 to 60, but it's decent. You'll have the understanding that is needed. If you're already experienced with functions, I apologize. There will be a little bit of an overlap with your knowledge probably, but I can guarantee there might be a few things that you will learn, new things. So the very first question that should be asked is, why? Why Azure Functions, right? I mean, we've been using a model different than functions, where different models, usually it's a full-blown program or some sort of service that is continuously running. If you're coming from on-premises world, it's Azure Functions, web applications, if it's either on-premises or in the cloud, containers and whatnot. Why functions? And it's actually going back to this idea of, well, it's not a secret. AWS, Amazon was first to the market with their offer called Lambda, which is same as functions, where you would only execute for certain task execution and then shut down, as opposed to continuously running a process and incurring cost and wasting resources unnecessarily. And what's interesting is that a lot of folks initially thought that, this might be a nice gimmick, but not necessarily for serious companies or large corporations, right? Big architectures. So if we look at the definition of what really Azure Function is, it's serverless solution that allows you to write less code, maintain less infrastructure, and save on costs. Well, great. That sounds like architecture more than anything else. Really, seriously, why Azure Functions? And the best example that I could think of is actually something that Scott Hanselman came up as an analogy, talking about building your own vehicle versus buying a vehicle but still maintaining it versus a taxi. And then I think the latest thing was something like Uber, right? So if we look at conventional stack where we have hardware and virtualization, operation system on top of that, potentially containerization if we have that, obviously runtime that has to present application and functions, and who's managing what. If we're talking about infrastructure as a service, then it's mostly all on the customers, on us, in other words, and very little on the vendor or abstracted by the vendor. So for example, hardware and virtualization is abstracted by vendor, by Azure, for example, when we're running Azure VMs. Everything else is on us: operating system, runtimes, installing applications, maintaining it, and whatnot. The next step is something like container as a service, right? So Azure Container Instances, or Azure AKS, Azure Kubernetes Service, or ACA, Azure Container Apps, where it's a step up because we no longer need to deal with the operating system, right? And yes, we have to manage containers, for example, but everything that is related to deployment, scaling, etc., is no longer our problem, at least not managing it in the sense of actually building, deploying. It's provided by the service, but everything that is related to runtime application functions or procedures, execution, still on us, right, as customers. Then we start talking about platform as a service, which is kind of ironic because that's where Azure has initially started. It was more about platform as a service and way less about infrastructure as a service. Recently, it has shifted, in my personal opinion, more infrastructure than platform, but that's a different story. And with platform as a service, I'll give you an example of Azure Web Apps, right? Where we don't manage hardware, we don't touch virtualization, we don't have to deal with the operating system patching and updating. We don't deal with the containers, right? Not even runtime. The only thing that we manage in a way is application and the actual code, right? Deployment of that. And that's fantastic, but this is where functions are coming in and basically saying, you know what, pretty much everything in this entire stack will be abstracted by the vendor. Starting from hardware all the way to the runtime, the application is becoming, even application in a way, even though it says customer managed, even application is no longer the customer concern, our concern. Our concern becomes just the function, just the logic that we want to write in order to implement our system, right? And it sounds like, why would you implement a system with functions where function is something small? But we'll get to that. Now, it's not necessarily a graph or a picture that depicts the progress, and that you should all find yourselves on the right side of this image. Not at all. Different problems require different solutions. And oftentimes I see customers and clients that are leveraging a little bit of everything, right? Platform as a service, which is a common thing, functions and infrastructure for certain things, and containerization. But I do believe that in the end, all of this will, in a way, converge. Now, if we're talking about functions, obviously, you need to express your logic. You need to be able to write in something. In my case, I'm very much familiar with C#, and I use that variant. Though in the early days of Azure Functions, you can actually use something that was called, well, still can, C# scripting. It's basically an option to provide express your logic in C# that resembles to the language. It's pretty much the same language, but you don't need to pre-compile it. You don't need to deploy any assemblies. You just write the C# and it's executed when the function is running. It's actually a little bit of a history. It's funny because back in the day, we could easily go into the portal, use portal as the editor for Azure Functions, literally create, store, and run without repositories and, all the unnecessary, air quotes, development processes. But throughout the time, it kind of became less relevant because we still want all the good practices, not necessarily the best, such as unit testing, testing in lower environments, versioning, and whatnot. The other languages that are fully supported, JavaScript, PowerShell. Interesting enough, PowerShell is quite popular and has a lot of use among folks that provisioning services and already familiar with PowerShell scripts, and they just leverage functions with PowerShell. You can also use Python, TypeScript, Go, Rust. These are officially supported languages. Now, in terms of hosting functions, this slide probably doesn't do the justice, but I'll try to break it down. So first of all, we have two options. Pretty much most of the options on Azure in general, hosting functions with Windows operating system or Linux. There are certain caveats depending on what you do and how you deploy your code, whatever it is, compile bits or Docker image or whatnot, or zip deployment. There are certain constraints. I'm not going to get into those because that's what documentation is for, but I want just to highlight the bigger important parts. First of all, in terms of hosting functions, functions have a concept called function apps. So that's how you group your functions in a function app. And function app can be hosted either with a consumption plan or a premium plan. Two plans out of the box. There's an additional plan that will be coming very shortly, I believe, during Microsoft Build conference, which I can only allude to the fact that it's going to be probably a middle ground between consumption and premium, because as you're familiar with Azure, if you're familiar with Azure, it's usually there's a gap between something that is standard and premium. So that third option will probably bridge between consumption and premium. So consumption, just as it sounds, you pay for per execution. So imagine your function, think of function as literally as a procedure or a function in .NET code, for example. If it's running for 10 seconds and consumes 1 GB of memory, you literally paying for those seconds times amount of gigabytes times whatever the price. The consumption plan is extremely popular because it doesn't require from you anything. You don't need to deploy absolutely anything other than the function code itself, right? Other than compile function, or if it's not compiled, whatever variant it's coming in. You don't have to provision any resources, which is extremely popular for low budget implementations. And not just only low budgets, I've worked with a few startups that want to quickly prototype. And before they make any serious investments and sort of seal their IT infrastructure, it is actually very easy to experiment with functions representing backend, but we'll talk about that a little bit later. Unfortunately, the downside of consumption plan is that you are basically, think of calling a taxi. You don't really have much of saying into what type of car you're going to get. You might be getting a sedan or a minivan or an SUV. Doesn't really matter. Well, in this case, it's only one type of vehicle that's going to arrive. I believe it's 1.75 gigs of RAM, something like that. It's enough to do even somewhat mid-level computation and not something that is memory exhaustive, just because you will run out of memory. In terms of temporary disk space, it's the same story. There are workarounds and whatnot, but if you find yourself exceeding consumption plan provided resources, you can switch to premium plan. Now, premium plan is, first of all, provides a few options in terms of compute and memory that you can select. But what it also provides, quite a few actually other benefits, is billing that is not based on gigabyte second. It's basically flat payment that you're making. But it only makes sense when you are finding yourself in a near continuous execution. So similar to, for example, on premises, if you have a Windows service that is running 24/7, but maybe making a few writes to the database once in a blue moon, obviously something like premium plan is not worth it. That's the consumption plan. But let's say you are receiving messages or webhooks that you're processing, and those are coming not every hour or so, but every second, then consumption plan doesn't really make sense because you're going to be paying as much as you're paying for a premium. So might as well switch to the premium plan. The other few things, again, there's documentation that talks in details about the differences between consumption and premium plans. But these are the things, for example, that I wanted to highlight. Besides the hardware options that we were talking about on premium plan that you can select, there is something that is called cold start. With consumption plan, because you're basically only running when there's a need. So for example, a message arrives on the queue, your function wakes up and processes it. Or there's an HTTP call that is coming in, your function wakes up and processes the HTTP request. Or there's a blob on a storage account that is getting dropped and your function is waking up to process it, right? All different options that you can implement with functions. You notice the same pattern. Your function needs to wake up and it needs to be bootstrapped, basically. And that cold start used to be an extremely poor experience in the beginning, back in 2016, when functions just got released. Thanks goodness, 8 years later, it is nowhere near to that experience. But there is cold start with consumption plan. With premium, it's pretty much eliminated because you can have always ready instances and you can predefine how many instances of your function would be ready to take in requests, and you can or have it as pre-warmed instances. Truth is that, you know, where's the lock, there's a key. Cold start could be worked around as well on consumption plan, because all you could do is have a function on a timer, like a cron job, that just periodically pings your function and wakes it up. And by waking it up, it basically pre-warms it, right? So again, you incurring additional cost of running a timer-based function, a cron job-based function, but it keeps your response times very short, especially for something like webhooks or HTTP processing, right, where request response is synchronous and you want to be able to respond as quick as possible. The other significant difference between these two plans is the execution time that is permitted per function execution. On consumption plan, it's capped at 10 minutes. So if your function is not done doing what it's doing for 10 minutes, it's going to be terminated. With premium, it's 30 minutes. Now, it's really interesting, always interesting debate with a few folks that always see the negative side of this time limit, saying, oh my God, why does the function has to be, why is a function limited to just 10 minutes or 30 minutes? Well, first of all, resources, right? You're paying much cheaper price on consumption, hence 10 minutes limitation. The second thing, the whole concept of function is to be something that is executed quickly, right? Almost like a burst of execution and then goes down. It's not intended for ETL processing or some lengthy batch processing. It's not the right tool for the job. If you really need that type of scenario implemented, then functions is probably not what you're looking for. And also, I would argue that in a lot of business applications, we don't want to have a method, because a function is very similar to a method, to be executed for 10 minutes. That's just insane, right? That means that we either having some performance issues or we're just doing too much that we shouldn't be doing in a single method. So that's just a quick overview. Any questions in the audience? No, we're good? All right.
So far.
Okay. Now, those are Azure Function Apps hosting plans, but it doesn't mean that you're constrained to host your functions only within Azure Functions app. You can actually host your Azure Functions with App Service Plan. Where is it handy? For example, let's say you run a website, right? You have an App Service Plan, which is always required for web app hosting. And App Service Plan can be utilized as a host for function apps, because you're already paying for the VMs that are running for the App Service Plan that are running the website, and you can also co-host Azure Functions. And if you think about it, it's no different from what we've done on premises a lot of times, because we would have an app server, application server, which would host IaaS for the web applications and Windows services for the background services and processing, right? Very similar concept. So that's on the left side. On the right side, you have full-blown Azure Kubernetes services. So if you're running, Azure Kubernetes cluster on Azure, managed by Azure, you can also deploy your functions as Kubernetes services, microservices, whatever they call these days, right? It's an option. So your investment in functions doesn't disappear if you decide to choose a different hosting. It can evolve with the architecture of your system. My favorite one, or the one that I recommend to most of people, is something in the middle, which is Azure Container Apps. And the reason why I'm recommending that is because Azure Container Apps is aligned with the cloud native, which is a funny name because I find very little native about containers because we're basically shipping our desktops, kind of. But the nice thing is that you can also host functions. Functions are fully supported on ACA or Azure Container Apps. So it's a really nice way of being able to move around different services and evolve with the architecture of your solution and not to be cornered into a single implementation.
Quick question on that.
Yep.
So when you said ACA can host functions, do you mean like a single function and that you don't have to have a function app? Or did you mean it still has to be a function app that it's hosting?
So you would have, yeah, it's very similar to function app. It's up to you because, so let me just go back in case someone is not familiar with the concept. A single function is obviously a single unit. It can be HTTP function, respond to HTTP calls, or messaging function. And we can put together those functions in a logical container or logical boundary called function app, which contains multiple functions. Now, when we want to scale differently different functions, we can break them into different function applications, right? Function apps. Similar story here. You technically deploy an Azure Function app as a container. And yes, it would be the same thing. They would be all residing within the same container, or you could split them into multiple containers. Does that answer your question?
Yep.
It's actually very similar. I know that usually the recommendation is to have Azure Container Apps. I know it has nothing to do with function apps, is to have a single service per container. You can have density. You can put more than one in a container. Not necessarily a good idea because then you cannot necessarily control individual scaling. Same thing would apply to Azure Functions. Now, in terms of the high-level anatomy of functions, it is extremely basic. It's like Lego. You have a trigger, you have an output, also known as binding, output binding, and you have your logic, which is the function. And that's really all there is to any functions. And because of this structure, this Lego-like structure, it is very modular. A trigger could be Azure Service Bus, storage queue, storage blob, HTTP request, event grid event, whatever you want. And the output could be accordingly anything that you want, right? So you can combine whatever you need. And the nice thing, you can also do custom triggers and custom output bindings, right? So for example, I'll show you down the road the possibilities out of the box, but let's say you have some service that you want to trigger custom functionality. You can create your own trigger. There are certain caveats in terms of scaling out. It used to be more problematic. The new SDK, I haven't looked into that, to be honest with you, but I think we are actually getting closer to being able to scale out custom triggers as well, but I'm running ahead of myself. Just a quick terminology, triggers and binding. So triggers, sorry, is there a question?
Yes, no? I have a question. So scale out is horizontal scaling. So how can you put together with the triggers?
Can you repeat the question?
Scale out this horizontal scaling.
Yep.
How can we put that together with the triggers?
I see. So the idea of scaling is based on the, well, I should step back. First of all, we don't have much saying in how functions are scaling out. It's based on the load, and you're right that it's related to the triggers, because triggers are the ones that actually triggering functions execution. There is something that is hidden from us. It's called scale controller. And scale controller is the one that is monitoring queue length, HTTP number of HTTP requests, and so on, and makes a decision how to scale out those functions. Now, on consumption plan, it is completely abstracted. We have no clue. All we know is that it's just going to scale, well, not infinitely, but close to that, because guess what? We're just going to be paying for the instances. And what's happening is, I'm going to give the easiest example is either HTTP or a queue-based trigger. Let's say we have one message on a queue, right? And that has arrived, and there were no messages before. The trigger is going to receive that message, and it will create an instance of a function, right? And behind the scenes, obviously, there will be something like a container, because it's not really VM. It's like a container that is spun off and is executed. And that one is going to live for about 10 minutes. Even though the execution took 2 seconds, that container will still live for 10 minutes. If there's another message coming in, that container will be reused, right? That function instance will be reused. Now imagine we suddenly got a flood of messages into our queue. And what's going to happen is the scale controller, which is in charge of the trigger, it will make the decision saying, you know what, I need to spawn off another instance of this function app, right? Another container, and it will trigger another one. Depending on the queue length and the algorithm that is found, it will basically scale up more and more and more. With the newer versions of functions, which I will talk in the second half of this talk, there's actually a more robust way to control scale out, as opposed to with the traditional, it sounds almost funny, the original SDK for functions. And what I was referring to with a scaling problem of custom triggers is that custom triggers do not know how to integrate with the scale controller. So when you create your own trigger, your custom trigger, it doesn't integrate with that scale controller, and therefore there is only one instance of a function that will be running. That's the idea.
Yeah, thank you.
No problem.
So is the order of operations that it's at least with a queue, and I imagine this would be with anything, that it hits the trigger, that's what's listening, and that spawns off the function every time?
Correct.
Okay.
Yeah, it's kind of left to right if you used to left to right, but if you're going right to left, you just invert the picture and that's it. But it's always trigger that is triggering the function, executing the function, and usually function results in some sort of output, right, which we bind to, and that's the next slide. So triggers, as we said, that's basically defines how a function is invoked. Binding to a function is a way to declaratively connect another resource to the function, right? It could be either input or output. So it's not just enough to have a trigger. We can also have an input binding, which means that on top of the trigger itself, we're also going to bind ourselves to some resources. Output binding is probably, well, I shouldn't say more popular, but I'll show a few examples to demonstrate exactly how it's working. All you have to keep in mind is that binding is what helps us to get sort of parameters into or data into our functions, and output bindings is usually how we communicate or how we output the results from the function processing. Now, what are the triggers that coming out of the box? Where's the slide? There it is. there are quite a few, to say the least. Blob storage, popular, and you can see it can be both trigger, input, and output binding. Cosmos DB, Azure SQL, which is very popular, surprisingly, well, SQL in general, I guess. Dapper, which is the framework that Microsoft is providing. Event Grid can be used as a trigger, for example, and output binding, but not necessarily input, which makes sense because, well, at least the original Event Grid was about pub/sub. HTTP and webhooks is probably one of the most popular because you can basically implement your entire backend or API services or webhooks with just functions, and so on, so on. Queuing has both the queue storage and service bus. There is at the bottom the timer one. That's the cron job that I was talking about. This one is probably the most different from the rest of the triggers because obviously it has no input or output binding because there's nothing to bind to. But it's just the fact that what it does, it triggers the function and there's no really any data that is coming with it. So for example, if you say, I want to execute this function every hour, or I want to execute this function every 24 hours, right? It's just a trigger is the cron job, right? It's going to wake up your function and it's going to execute it. It's really handy for certain processes that have to execute on schedule and whatnot. Anyways, I'm not going to focus too much on this, and the documentation is probably the best resource to consult with to see if there are any additions and changes, modifications. Here's an example of an Azure function. And here I have to explain or provide a little bit of context. As I mentioned earlier, functions have evolved since 2016. It started as something very primitive where you could literally write your C# kind of code, which is more C# scripting, right? Paste it in the portal and execute. And then it evolved into, okay, we want something that's compiled. What's the simplest compile option that is closest to the scripting? Well, static class with a static function. Initially, it wasn't asynchronous, it was synchronous. Later, it started supporting asynchronous option. And down the road, there was also full support for DI container, and you could create non-static classes, right, that would be instantiated with non-static methods and so on. But no matter what you do, what flavor of functions you're writing, the concept also always remains the same. You have a body, a method, that is decorated with a function name that attribute is indicating to the function runtime what's the name of your function. And the class itself doesn't really matter. It's just a container, right? A storage place. What matters is the function itself. And I'll show you other variants as well. So for this case, it might be a little bit, disorienting, but the idea is that I have a method called runAsync. It's just a method name. The function name will be blob copy because that's what we're telling Azure Functions runtime or the SDK, what name to assign to this function. And you'll notice that there's a blob trigger attribute and a blob attribute. So blob trigger is the trigger. Blob is the binding. Okay, it's a little bit confusing, but bear with me. And what we do is we decorate with these attributes our parameters that the function is declared. So for example, blob input is a string that this blob trigger is looking at. Well, actually, technically, it's not what's happening. What's happening is there is a container called simple images, and any blob that will be found by the trigger in that container will execute this function and will provide or inject a string that is pointing to that blob with the blob name and everything else, right? So this is the trigger, right? For every blob that will be found, new blob that will be posted to the storage account. And then there's blob binding to this parameter called blob output that is pointing to a different storage container. It will use the same blob name as from the trigger, right? The intent is file access right. And what we'll do in this function is we'll just log something that we're copying, whatever, and we will stream or copy the input stream to the output stream. So what did we actually do? What we did is we created a function that automatically detects changes in a blob storage account called sample images, and it copies every image that is added to a new destination, another container called sample images copies, replicating the name and obviously the data, right? So it could be a simple backup mechanism. This is a common technique also, for example, to do image resizing. Let's say you have a website where someone is uploading an image and you want to generate a thumbnail, right? A smaller image. You can imagine that this is a very similar concept, except instead of just copying, you're probably going to do some mutation of the image, scale it down, you're resizing the image, right? Something like that. Maybe you're going to store several dimensions of the image. Same idea. But you don't have to do it in a single function. You can actually split it into several functions. Let's say you have thumbprints of, 100 by 100, 256 by 256, and whatever the size. Each one of those sizes could be a separate function. So another way to describe function architecture is that we're striving to break implementation to have a single concern only, right? And we tend not to bulk together the work. And yes, this will be multiple executions, but it's actually in the long term easier to maintain and evolve when there's only one responsibility, because guess what? As we used to normal .NET or any programming, we strive to have as less logic in the method that is not coherent or is not does not have a single responsibility, right? We strive to have a single responsibility as much as possible. So that's one example.
Is that blob name, is that a reserved name, or you put anything you want there?
Oh, you can put anything you want. You can actually define a string variable here, right? That would be assigned, called blob name, that would be assigned the name. So for example, instead of saying log information, you want to say, you literally want to say what was the blob name, right? You would be able to do that. The other thing that I skipped, thank you for asking that question, I skipped the 6 and 7, which is cancellation token and the logger. It's kind of funny because, well, cancellation token is something that we are getting used to, well, we're already used to in .NET, that it's just passed in, flown into the function or any method and can be invoked. So it's the same concept, really same concept. These are optional, by the way. It's sort of declarative injection. If you don't declare it as a parameter, it won't be provided to your function. But if you do want to respond to cancellation, you can. Same thing with the iLogger. If you don't want to log anything, just omit this parameter. But if you do put it here, it will be injected. That's just a convention. The next one.
I have one last question.
Yeah, go ahead.
Can you automatically inject configuration?
Excellent question.
Because I had that problem today. I put in a constructor.
Yes, you can. And I think what you described is actually the newer SDK. So we'll get to that and I'll show this. Technically, there are certain things that you can inject out of the box because they are in the DI container. But there's a big difference between In-Process SDK, Functions SDK, and Isolated isolated worker model or isolated worker SDK. And I'm going to talk about that.
Okay, thanks.
But does that exist in .NET 8 as well? That is in .NET 6?
So the .NET version is less important here. It is the SDK that matters more, right? But this is .NET 6, this is .NET 8, would work the same way.
Would it be wise to put it in a try and catch, just to catch anything that might happen? Any kind of error?
I really like this question. I really like this question. So the whole error handling or exception handling is an interesting topic because it really depends how do you want to respond to the failure, right? If you cannot tolerate failures, then absolutely putting try catch is recommended. But if there's certain recoverability or retries that are baked into the scenario that you're dealing with, then it's the opposite recommendation. Do not do try catch. Do not handle exceptions. Let them bubble up. A good example, and this is the modularity of functions. If you do an HTTP triggered function, obviously you don't want to bubble up that exception, right? You want to provide some error code with certain description, but it makes total sense to do try catch. But if you're handling messages, like Azure Service Bus message, you do want to retry because retries are built into the service bus because the message can be redelivered several times. So
Gotcha.
I'm going to talk, that's the cherry on top of the cake towards the end of the session where I'm going to talk about some advanced scenarios. But I will get back to that. It was a good question. Can you hear music?
Yeah, is that streaming from a function?
Oh, that's interesting. Anyways, startup class.
That's
So
spot.
because I'm my focus right now is on this older SDK, or I don't know if it's older or current or legacy, how to call it, in-process SDK. The startup class was kind of weird, to say the least. So first of all, you had to have the assembly level attribute, which would indicate what class represents the startup, which was, in my opinion, very unfortunate design decision. I think someone is online is talking, is not muted.
Oh,
Okay, I just muted him. That's fine.
okay. I'll disable the mic for everyone.
That's okay. Thank you. So that was the first thing that is kind of weird because it's not the conventional .NET approach, for example, right? You need to, if you used to writing ASP.NET or console applications or Windows services, this is not what you do. And then when you have the startup class, you had to extend a special class called function startup, which would provide you two overrides or two options to override configure app configuration and configure classes, methods, where configure method would be injected with iFunction host builder, which would give you the way to get the configuration. So it's just configuration or get to the services and whatnot. From this line over here and down, that looks more like a standard .NET, the conventional .NET that people are familiar with, when you can have your service collection and register HTTP client and add your services, dependencies, transient or scope, and whatnot. So that was pretty much how you would bootstrap your function app for all functions within that function app. Again, not ideal. We're going to expand on this a little bit later. Then a function, remember I mentioned that we started with sort of scripting and then we evolved into static classes and then asynchronous support was added. And the way I recommend this day to actually write functions as proper classes, services that you can inject. So for example, here's a class called concierge. It has a constructor with all of its dependencies, and those dependencies are injected by functions runtime. And then we have the actual function, which I happen to call the same name, which does the work. In this case, it happened to be an HTTP triggered function. How do I know that? The HTTP trigger. And what it does, it outputs a message. How do I know that? Well, there's a service bus, but it's not a trigger, it's a service bus output binding. Right? What it does, basically, it responds to an HTTP call, emits a service bus message to this queue called LC360, and at the same time, it also has the response right there. Okay, result if the processing is successful, which is very similar to ASP.NET, right? Very similar. The one difference you'll notice there is a singleton attribute. A singleton attribute, usually what happens, if you remember, I've mentioned that if trigger is getting invoked multiple times, there's a scale controller that actually gets to decide if a function app should be scaled out into more than one instance or multiple instances or not. And sometimes you don't want to do that. So for example, let's say I have some legacy part of my system or some part where concurrency is undesirable, and I want to limit invocation of the function to one instance and one instance only. That's where you would put the singleton attribute, right? It acts as a semaphore. It doesn't allow any other invocation of the function to continue until the one that is executed is completed, and the rest is queuing up. Now, this is the answer to your question, Ari. This is how you would inject your configuration, right? You would be able to basically pass it into the constructor of the class. And the previous slide right here, if you can get your configuration object, then you can also register it as a singleton, right? To be able to access from the functions. So that's the idea. Now, and it might sound a little bit weird. Yes, function runtime is identifying this method as the function, but what it does behind the scenes, it actually creates an instance. It will create an instance of a class. It will inject the dependencies and then invoke the method. It will not skip the method. Now, one thing that I kind of unintentionally left out is this IAsync collector. IAsync collector was a very nice in the in-process SDK abstraction, how you emit certain things. So for example, if you want to emit messages to service bus or event grid, you would use an async collector of whatever the types that you are emitting, event grid message or service bus message or event house message, right? It was a very nice abstraction to allow testing. For example, with the new SDK that we're going to talk about in a few minutes, it's very different. So not everything new is always better, ironically. The other thing that I should mention is the authorization level, and that's an important one. Authorization level is just enumeration. There are a few options. There's anonymous, function, user, something else. The default is function. What it means is that when running locally, there is no authorization required because it's local, there's no security enforcement. When you're running in production and no debugger is attached, then a function is protected. And it's protected in a way that calls to the functions will never make it. And either you have to provide an API key, they call it code, which you can generate on the portal, in the portal, or you can hook into other options. Managed identity, for example, is also an option. But that's a way to guarantee that no random users will be calling your HTTP trigger. Let's say you implement a function that acts as a webhook. You only want permitted users or parties to call into your function. So you would share the function API key with them.
So question about this implementation that you've got there.
Yep.
I've seen two examples in your code. So what's best practice? Is it public static functions? Or is it not using static? As I see, like to get configuration and everything, you're using the constructor approach that I ended up having to use. But that, of course, would preclude me from using a static function. So is there a benefit to using the static actual
So
function?
the best practice is never to have the best practice. It really depends. And now the fact that I'm a consultant is coming through. It really depends on what you're trying to achieve. When I know that I don't have any dependencies that need to be injected, so no services that I register that are required, I would skip to, and I would do static. But the moment you have to have dependencies, for example, I have here an authenticator and third-party API and Unicode, sanitizer, etc. It basically requires you to have a class-based approach that is not static. Now, over the time, what I've seen is that probably this model is just easy to follow and be consistent, right? The fact that we instantiating an instance of this class, injecting dependencies, and then invoking the function versus having invoking the method versus having a static class with no constructor injection and just invoking straight the method, the differences are neglectable.
Yeah.
Right?
Well, it seems
So-
like just write your code the way you normally would, where of course you
Precisely.
static if you don't need it. Yeah.
Precisely.
Got it.
It's also aligned with web developers. So anyone who's doing ASP.NET Core, it's consistent with what they used to. Anyone who's doing standard development, this is where you find most of the documentation, and any user or any developer that continues this code base will find themselves in something that is more familiar, and they can find resources, documentation, and know what to do and how to change. Sometimes being consistent is a good practice. Let's talk about settings, because it's an interesting story, both in both SDKs. So first of all, when you're running locally, the only way to specify configurations for Azure Functions is to use a file called local.settings.json, which should not be committed into your repository because it's user specific. That's why it's called local. And also because it's not deployable. It's not something that can be pushed to production. It's basically a JSON file. It's flattened in this case. And you'll notice that sometimes there's a colon is the hierarchy of objects, sub-objects. And sometimes there's also underscore. And that's the difference between Windows and Linux. Again, you can refer to documentation to see all the details. The one thing that I will mention is that this function worker runtime is a magic value, because that basically tells functions runtime how to execute your code. Not only how to execute your code, because obviously other than .NET, it could be JavaScript and whatnot, Python. It also tells which SDK to use. Azure Functions SDK, not .NET SDK. There's also certain standard things, such as Azure Web Job Storage. That's kind of hard-coded in the Azure SDK, to be honest. And that's the storage connection string that you need to have, because Azure Functions rely on storage behind the scenes. Usually when you deploy an Azure function, you also deploy a storage account. They go together. Everything else is pretty much custom, except obviously Azure Functions jobs host. This is an override for the logging, right? So for example, in this case, I'm taking the trigger, they call them extensions, for service bus, and I'm defining max concurrent calls 1. Why do I do that? Well, when I'm running locally, for example, with Azure Service Bus, and let's say I have 5 messages in my queue, I don't want function to fire 5 concurrent threads and start debugging in parallel. I just want 1 message at a time, right, in a serial manner. And that's how you can override the defaults of every trigger. Now the question is, okay, this is great, Sean. This is locally. What do I do when I deploy to the portal? And unfortunately, I didn't take the screenshot in the portal. And this is where I'm going to apologize on behalf of Microsoft because it's ugly. What you need to do is you need to define in your Azure Function app environment variables. And basically, similar thing that you see here has to be transitioned into environment variables. Yes, you can use app configuration service. Yes, you can use Key Vault or combination of the two. Not for everything, unfortunately, because, for example, things like Azure Service Bus Trigger doesn't play nicely with the Key Vault. There's an open issue about it. Azure Web Storage Account has to have a connection string. Sometimes it doesn't work properly with Key Vault. So there are caveats. Now that's one configuration file. There's also, this is configuration file that is specific to configuring your function. And it's kind of funny, even though you see the host name here, it's because it's all in process. It's all running within the boundaries of the same process, the host and your function. There's a separate file called host.json, and that file is specifically for the host, for the function runtime, which specifies things. Again, you see the extensions, service bus trigger. For example, you can specify, I want to allow at most 3 concurrent message processings. And you can specify in terms of logging. All functions should be logged at the level information and lower, higher, whatever it is. So debug error information. But if I have namespace that is Microsoft or Azure Core or Azure Messaging Service Bus, I only want warnings and errors and exceptional messages, exceptions, criticals, because I don't care about informational messages or debug messages, for example. This file is getting deployed as part of your function app, okay? And it impacts all of your functions. Why am I emphasizing this fact is because if you have more than one function of the same trigger type, so for example, this is Service Bus. Let's say I have 2 different functions that triggered by Azure Service Bus messages on 2 different queues. The configuration is going to be identical for both of those because they live under the same function app. If you need different configuration, you have to split them into 2 different apps. Okay, keep that in mind. Now, in terms of the cost, especially if you're running on, if you're utilizing an existing app service plan or if you're using consumption plan, the cost is going to be the same. It's identical, right? So now let's get, because I kept dancing around the old SDK, new SDK, let's just make it official. What I showed you so far was the In-Process SDK, the one that was deployed originally or released originally in 2016-ish, 16, I think. And then in 2020, the Isolated Worker SDK showed up, knocked on the door, introduced itself with no feature parity whatsoever, but with the concept of, hey, we need to split between the host and your function app or your functions, because mixing them together is nothing good. How do you distinguish by just looking at something like configuration, .NET versus .NET Isolated? This little string is telling runtime, Azure Functions runtime, not just the fact that it's .NET based function, but also which SDK to use. And the other thing that I wanted to kind of show, this is from one of the latest updates from the team, is that Isolated Worker model or SDK is what's going to move forward. In-process model will disappear, most likely by the next LTS, which is .NET 10, right? And even today, it's funny because if you're trying to deploy in-process SDK functions into Azure, you cannot, because they kind of behind a little bit. You can only, if you want to run on .NET 8, so you have to wait probably another month, and then you'll be able to do that. But if you're using Isolated Worker, SDK, then you can deploy already today without any problems. And I'll talk about this because there's some caveats. All right, so now we know that there is the older SDK or the in-process SDK and the isolated SDK. And I know the daunting feeling of what I need to upgrade. Really? The truth is yes. And not only because you have to, because you actually get some of the biggest benefits that were the drawbacks of the in-process SDK. And those are, well, let's first of all look at the anatomy of the isolated worker. Separate host from the worker is extremely important because the previous SDK combined the two together. As a result of that combination, the problems that this new isolated worker SDK is solving were not trivial. For instance, assembly version conflicts. If your host and worker are collocated, combined into a single process, right? It means that you are forced to use one assembly version. Let's say you're using Azure Storage, and in your code, you're referencing a certain version of that assembly, of that SDK. But Azure Functions runtime, because it needs to have triggers and whatnot, is using a different version. You're potentially running into a scenario where there's going to be a version conflict. And that's a very real problem with in-process SDK. With the isolated worker, because they separate it, it's no longer a problem. Host can have its own version, worker can have its own version of that assembly. And by the way, the communication between the two is gRPC calls. And as you know, that doesn't really impact anything, as long as gRPC is supported on both sides, which usually it is. So that's one problem solved. The other one is controlling the startup of the process. The problem with the host merged with the worker in the older SDK was that the startup of the host was the startup of the worker. But really, their lifetimes are different because host might live for a long time. Your function should have a much shorter time, right? So the startup of your function needs to be every time the function is bootstrapped, every time it's started. But that was not the case in the older SDK because it was tied to the host. So it was only once startup. Result in isolated worker SDK. Everything that has to do with standard hosting and DI, that was really painful. If you remember back a few slides where I showed you this very strange API where an object is injected and through that object we can get to the services, that's because the previous SDK, in-process SDK, was working around the fact that there was only one container. And that container needed to be shared with the worker and also, what's the word I'm looking for? You spawn off a new process and you are creating a new DI container, but you don't really create a new DI container because you're creating a copy of the shared DI container that host is running. With the split in isolated worker, that's not a problem because this is a very standard .NET host, right? With the builder API that we're familiar with, and it gets its own container, but it's bootstrapped and torn down. So nothing is shared. And obviously the elephant in the room, different .NET versions, because the host can be on .NET 6 or on .NET 9 or on .NET 8. Doesn't really matter because our worker is using whatever the .NET that we can use or want to use in the organization or for our solution, and that's it. gRPC doesn't care. Now, what the code looks like? Well, extremely similar to what you would see with, for example, ASP.NET or console application. You have your main where you create your host and you run the host. And the creation of the host is just chained calls of certain methods up to the build, right, to create your functions host. These are the standard things: configure functions worker defaults, a very important line. A squiggly there for a reason, I'll explain in a second. Configure app configuration. This is where you can inject additional sources of your application configuration. So for example, if you want to have a file that is checked in, such as appsettings.json that we're familiar with, you can do it here, right? You can add additional sources. If you want to use .NET secrets, right? So that you don't have to check in any secrets, local secrets or local configurations or overrides. Because, for example, my SQL server is called Sean's Beautiful SQL Server and not localhost 1433 or something like that. We can do that. Configure services, that's where all the DI work is taking place, right? Where you register your services, your classes, whatnot. And configure logging is where you override logging, set up new loggers, mutate the existing configuration out of the box and whatnot. Now, that squiggly is kind of important. This is where the magic is happening. The previous slide I showed you that there's gRPC communication between the host and the worker. So for example, when HTTP call is coming in, the trigger is sort of living on the host side. The host is taking that information and passes it to the worker, to our function as gRPC call. Our function doesn't see it as gRPC call. It's all abstracted. And when it's returning whatever a message or HTTP response, it's also traveling through gRPC, but it's abstracted for us. And that abstraction, the implementation of that abstraction is actually wired through this little method. And if you forget to put that method accidentally, or you comment it out, the side effects are actually very funny. Your worker starts your worker process, but there's absolutely no communication between the host and the worker. So you put in messages on the queue, you invoking, opening browser and pinging your function, you're doing whatever you want, but the function is just running and doing nothing. That's where you start pulling out your hair and realize that this little line is missing. So just be aware.
Hey, Sean, you
Yeah.
do have a question sitting there.
Come again?
There's a question in the chat.
Question in the chat. Let me just quickly look at it. Host, is the colon or which triggering function or something different? Yes, I think we kind of covered that. So the host is responsible to invoke your function app, your individual functions. So host is technically working with the triggers, right? Trigger is an abstract concept. The host is responsible to delegate the HTTP calls, all the trigger calls to your function, and then propagate that back to the external world or external services, right? A good example, HTTP. A request is coming in, it's handled by the host. Host is wrapping that in. Let me just go to the slide because it's easier to do it that way. So let's say HTTP calls coming in, host is taking that HTTP call, takes the headers, the payload, everything, converts that into gRPC call. That gRPC call hits the worker runtime. The runtime is converting that into the format that our function understands with all the parameters, all the CI that, DI that needs to happen. And then when the worker is returning HTTP response, again, the function's runtime is taking that response, HTTP response, OK result or whatever, turns into a gRPC call. gRPC call, which lands in the host, is then translated to the actual response that is going to the browser. Okay, so it's sort of a layer in between our function and whoever is calling it or triggering the function. What does the function look like? Extremely similar. Those that have good eyesight and sharp vision will notice that the only difference is that the function is no longer function name. The attribute is now function. That's the quickest way actually to detect if this is old SDK or new SDK, especially when you're going through documentation or samples or blog posts. You're searching for one type of SDK and just quickly look if they decorate it with function or function name. If it's function name, that's old SDK. If it's function, it's the new SDK. And then very similar, except if you look at number 2 and number 3, instead of HTTP request and async result or iResult. It's something weird called HTTP response data and HTTP request data, which is like, seriously, what are we talking about? And that's because the back in 2020, initial implementation of HTTP trigger deviated from the ASP.NET API, ASP.NET Core API. They created their own abstraction because it was, well, it is still RPC, and they needed the mapping. They came out with their own types, unfortunately, but don't worry, I'm going to talk in a second about alternative. And then you can see exactly the same thing, authorization level, HTTP trigger as a trigger name, defining your own route. You can also now inject certain things similar to before. For example, a request ID, it's literally the request ID. You can have certain headers injected as well. And then you have an object called function context. Originally, the idea behind this is that you would get everything from the context. If you need a logger, you could do get logger. If you need function information or function invocation information, you could get it from execution context. You don't have to. Now in 2024, you can actually inject it into your class, assuming you're using non-static class, and just work that way. It's much simpler. But I feel obligated to demonstrate because if you find the Isolated Worker SDK samples, you might see it with this format. And then when you want to get a response, you have to take the request, create the response, and stream the response back. Now, gladly, as I mentioned earlier, the functions team, once they got to a certain level of feature parity, they reviewed their HTTP implementation, and they introduced something that is called ASP.NET Core Integration. I don't know why it's called ASP.NET Core Integration, to be honest with you. But this is basically on par with what the older SDK was doing. And it's also 100% aligned with ASP.NET Core. So the first thing is, instead of having that configure functions worker defaults line, you have to replace it with configure functions web application. Once you do that, your function implementation turns into what's at the bottom, where you have the conventional IAction result, an HTTP request, and you just return an OK result or whatever the result or with the status code that you want. So basically what we're all familiar with and used to. The only problem, if you remember, I showed you earlier an example of a function that had to be executed only one instance at a time. That is missing in the new SDK. You cannot have it. There's an open issue. They thinking and trying to implement it, figuring out how to do it. It's not trivial because of the gRPC in the middle. For time being, you can work around it by implementing your own, what it's called, the word is escaping me. Not a singleton, that's the attribute name. Semaphore. You can implement your own semaphore using semaphore slim in .NET, right? To basically block all the HTTP requests until the current one is executing. But that's an option. So this was actually implemented, my memory is failing me, somewhere between 6 to 12 months ago. From that point in time, we got closer to almost complete parity with Azure Service Bus Trigger a little bit later, but we're almost there. Improved configuration. Yep.
On that previous slide, that you're declaring the logger that's subject inside the get logger. Is that just the name of the class that since it's so get logger, and then in the type you have inside there's called appointment scheduler queries? Is that the name of the class? Is that what you're? Because there's not. I'm assuming it's the name of the class.
Sorry, I apologize. It's cutting out a little bit. Could you?
Yeah, the line 5 there, and the get logger, that object inside of that's inside the type there. That appointment scheduler queries, is that the name of the class itself that it's?
Yes, yes,
Okay,
yes.
gotcha, okay.
Yeah, absolutely.
Okay.
So
Where that- Gotcha, okay.
usually what I recommend, you can get a generic logger or iLogger, but usually I recommend folks to get a logger for the type that they run, the code is running in, because then when you look at the logs, it makes more sense, right? Because you know which class it was logged in. Absolutely.
Gotcha, okay.
Hey, Sean, how many slides do you have left? Because I think it's 8 o'clock, so I don't know how good everyone looks on time.
I have about 6 slides left. If that's
So,
okay. So another
do we-
10 minutes.
What are you guys good with? Like 6 slides, 10 minutes?
Yeah.
Okay, we got it. All right, go ahead.
We can cut short, but we're almost at the end, which is a
Yeah.
good thing. So the improved configuration I was talking about, you can register your own settings sources. So for example, if I want to deploy certain configurations along with the code rather than providing through the environment variables and whatnot, I can actually do so, again, aligned with ASP.NET Core, aligned with standard 8.NET. In terms of logging is not a success story, in my opinion, because it's a bit convoluted. I'm not going to go into details. Yes, you can customize. So for example, you'll notice here when I'm running with the debugger, I add a console logger so that I can see more details. But then for Microsoft itself to log properly, you have to remove a certain rule which is registered by default. There's an issue about it and there's documentation about it. In my opinion, it's ugly. And I think they will resolve it once they have gone through the big rocks first. The huge improvement of the Isolated Worker SDK is introduction of middleware, similar to ASP.NET. And think of middleware as the pipeline that everything is going through. You can register middleware, you can specify when the middleware should be invoked, and you actually have the middleware. So the middleware is basically something between the trigger and your function on the way in and out. Okay, so really quick, how do you register your middleware? Well, when you basically that magical line that wires up everything, you get a builder that is passed in, and you can say use when. It's a weird API in my opinion, but basically use when this middleware, and this is the predicate. The predicate can be expressed as a simple condition, or it can be as a class. I prefer always to have it as a class, because then you can test it and you can express it, and it's kind of reads nicely. A predicate is usually based on the function context. Function context can tell you input bindings, right? You can figure out, so for example, this specific one is checking if the function that is getting invoked or getting triggered is an HTTP function. If it's an HTTP function, then this middleware will be part of the processing pipeline. And what the middleware looks like, extremely simple. Just like ASP.NET Core, you have an invoke, which gets the function context, and the next delegate. When you call in await next, you are either calling for the next middleware to be executed, or the end stop, which is the function itself. Anything that you put before this call is happening before the function invocation. Everything that you put after is happening after. Now, why this is important is because it opens up so many opportunities. Exception handling, which we had a question about. Should I handle exceptions or not? And I'll give you a quick example. Context back, where you can pass via context items things from middleware to another middleware to the function and the other way around. You can do stamping, right? Timestamps, for example, HTTP header stamps, etc. You can create auditing. So your function is getting invoked and you want to audit that it happened, not through the logger, but something else. It's a cross-cutting concern. Now you can remove that cross-cutting concern from all of your functions and put it into the middleware, a single spot. And you can do recoverability, which is phenomenal for something like Service Bus. I have 2 blog posts specifically about that topic. Sorry, my dog is telling me that I need to wrap up. And with this, I will probably end in 2 minutes. it's not something that is easy to digest, but I'll walk through real quick what this middleware is doing. It's working on service bus triggers, right? You can see here that we basically getting the metadata for our binding, and we are taking the input. The input for service bus triggered message is obviously service bus message itself. And what we do is wrap it in try catch, and we call our function. When the function is executed, if everything is great, right, assuming that I can have access to the value, to the incoming message, received message, this should not be the case that I cannot access it. That would be a critical error, but who knows? What I can do is I can audit. I can literally clone the incoming message that we have successfully processed. I can clone it as I can send it to a destination, let's say audit queue, right? And wrap it up. Because I can wrap it up, well, technically and I will wrap it up. So what will happen is we will process our message with the function, and we'll have a copy of the processed message, audit message, in a separate queue. That's one scenario. Another scenario is our execution of the function is failing, and we're going to get an exception. And if we get an exception, then I can play a game of retries, but not just sequential retries in a loop, but rather retries with back off, right? Because I can play this game of, oh, you know what? I want to retry, but not immediately. Let's say I have a certain number of immediate retries, but after that number of immediate retries, what I'm going to do is I'm going to say, you know what? If I'm exceeding these retries, do me a favor, clone the message, schedule this message for a back off period, right? And return. When I return from function, it will complete the original incoming message, but there will be a scheduled copy that will come back after a back off time. So now I can create a sophisticated execution of my message-based triggered functions, where I can not just retry immediately, but I can also have back off period and then retry again. And if it comes to the worst, when I had all my immediate retries and all my delayed retries with backoffs failing, you know what? I can actually do something nice. Rather than dead letter the message, I can clone the message, put it on the error queue, and complete the function, which is funny because when function is completed, again, the message, incoming message, considered to be successfully processed, but I will have a copy of that error put on a separate queue, and I can have monitoring, Azure monitoring that one that would alert me that I have failed messages, which I can later retry. So you now see that with middleware, you can actually build something very sophisticated and very interesting, right? Now, is it always a single output? No, it's not always a single output. You can also have different types of outputs. I'm going to skip it because it's less important, but keep in mind that it doesn't have to be I'm only returning one type of response. It could be multiple. It could be storage queue, such as in this example, with HTTP, because it was an HTTP request, I have to provide HTTP response, and could be also event grid with Twilio on top of that. I'm going to skip this slide, but basically it's the what I was talking about, that async collector or collectors, the concept of collectors for output binding is gone, and you have to use SDK types. Right, so it's a little bit unfortunate because now you need to know every SDK type in order to output things, but it's a small price to pay, to be honest. Where it's a bit more difficult to digest is when it's coming to testing, but I have good news because there's full parity with In-Process SDK. And because In-Process SDK didn't have a good story for testing, same thing applies to Isolated Worker SDK. There's no good testing story today. There's an open issue. They're working on that. They're thinking about that, what it means. But unfortunately, not there. You need to sort of do integration testing if you want to do it properly. So this brings us to the final question. Should we migrate? And the answer is yep, because you have to. Remember, In-Process SDK is going away. .NET 8 is the last version where you will be able to use it. With .NET 10, it will be gone. I'm referring to long-term support versions. Short-term support versions, I usually don't consider because it's not intended for production usually. And with that, I thank you so much for staying with me almost for an hour and a half. Hopefully this session was helpful, and keep in touch. The funny thing about Teams is that it's filtering out all the claps.
Oh, yeah, all the clapping, yeah. Well, Sean, thank you very much. That was really, I think everyone enjoyed it. Did everyone enjoy it?
Yes.
Hey, everyone wake up. That's good. Kidding.
Thank you, guys.
We did record this, so we did have a few like weird technical things where like every about 90 seconds, the TV would just blank out for some reason,
But it was still good there.
but it was fine here, which I think it's just, this is just a crappy TV.
So the recording will probably be good.
The recording will be fine, I'm pretty sure. If I'm wrong, oh well. So I'll make sure that link is posted. I'm sure you'll want a copy as well, Sean. Thank you very much. This was incredibly interesting. Hopefully you'll present again for us soon, and that'd be great. And we'll go ahead and end this for the evening and see everyone next month.
I'll be
Thank you
delighted.
all.
Thank you. Thank you. Have a good one.